So welcome everyone to our Underwater Homeowners Association meeting. We continue meeting online, and eventually we'll get back to our live sessions, which we're at the Hibiscus Gallery. The Hibiscus Gallery still isn't ready. It has some renovation, but we'll meet again at Pinecrest Gardens as we used to before the pandemic. I know our chair, Brian House, will be joining us shortly. But in the interim, I just wanted to just sort of welcome everyone. Thank you for continuing to participate and understanding that we've been at this as a Zoom underwater group for a while, and I'm just grateful that you're still here for this time. But this is almost like TV binging. Like you can either sit it during its program time, or you can just go to underwaterhoa.com and click on meetings and just watch and fast forward through the work. So I also want to sort of obviously acknowledge Adam, who's my studio manager and oversees, among other things, my entire social practice, and Jamal, who is serving as an intern through the MPS program here at Underwater HOA. And with that, Adam, I think I'm going to turn it over to you. And sort of get started with our introductions. And you need to unmute yourself.
Thank you very much.
Sure.
So I'm going to go ahead and introduce Keene, Dr. Haywood. He was one of my professors when I was in the Master of Professional Science program at the University of Miami. He's a senior lecturer in the Department of Marine Ecosystems and Society at the Rosenstiel School of Marine and Atmospheric Science at the University of Miami. His background is a mixture of geography, emphasizing GIS and the environmental humanities, and media production. His focus has been on the implementation of effective uses of technology in the field to gather data, document research, and disseminate discovery to the general public. He's consulted with explorers, video producers, and educators on how to best approach the use of technology in the field. He's also interested in how writers have explored different geographies in the natural world, enabling a better understanding of our context within it. I could talk a lot about Keene because of the time that we got to spend together. He's awesome, and I'm really excited to have you here. Thanks, thank you for joining us, and I'll let you take it away.
Okay, thanks very much, Adam, and Xavier. Thank you all for inviting me to be part of this. Jamal, thanks for your invitations and everything. So yeah, happy to see everyone, and glad you could be here this evening. So I'll just get started. What I'm going to do is talk a little bit about Expiration Science, which is the track that I coordinate at the MPS program, and then talk a little bit about how that links to citizen science, and then how that links basically to sea level rise initiatives here in the Miami area. So I will go ahead and get started with that and share my screen so you all can see that, and we will go from there. Oh, oops, let me just. Okay, so can everybody see that?
Looks good.
Okay, all right. So I'm going to start out with Expiration Science, and then move into citizen science, and then we're going to move into sea level rise stuff, sort of connecting them all together. So this. Okay. So Exploration Science. A lot of times when I mention Exploration Science, people sort of go, well, what is that exactly? It sounds really interesting and cool, but what is it? And so I say, well, it's a way of combining a number of skills that are sort of centered around observing the world around you closely, documenting what you see, and communicating that to other people. When you think about exploration, people go out, they see new things or find out new things, they document what they see, they communicate it to other people, they observe it. And so that's sort of the pillars of exploration. And basically you're, trying to disseminate discovery to the world. And so it's sort of a directed way of understanding the world by combining a number of different things. I really look at it as a combination of skills, techniques, and approaches versus sort of like a formal discipline. And so some of the things that we teach in the program in my track is media and technology for communication. Adam was in my media production class. Documenting, collecting data, and documentation of research and work in the field. Students get some specialization training, whether it's boat handling or diving skills, but exploration obviously can encompass a lot of specialized skills depending on what you're doing and where you're going. There's also a course around planning and expedition skills, dealing with logistics and group dynamics and ethical, ethics, especially when working in other countries. And then also, elements of transportation. You got to get to where you need to be working. So is that a sailboat, powerboat, on foot, animal, how is it? So we there's a boating class that we teach at Erasmus. Sometimes I've taken students on sailing trips to various points in the Caribbean, the Bahamas, Channel Islands on sailing vessels. So they get to learn how to do some of that. So, so really who is a scientist and explorer? I mean, we say the word scientist and we say explorer, we kind of have this preconceived idea about what that might be. I think it's sort of a stereotypical image that most people have. But basically, who is that really? And I look at it as basically, where I'll use this quote from John Fitzpatrick, who's a professor at Cornell in the ornithology program there, that basically in his book, Citizen Science, Public Participation in Environmental Research, which I've used in my class and in Citizen Science that I teach, I used to use this textbook. It basically says every human in the world is born a scientist. So, we use the term scientist now as kind of we sort of have a certain stereotypical image of what a scientist kind of is, but basically, a scientist and a scientific way of thinking about the world is really this organized, collective expression of human curiosity. All humans are intensely curious. We want to know and understand and make sense of the world around us. And so in that sense that, the root of the word is to know, scientists want to know things, they want to understand things, and we all have that in us. So again, I like this quote from John Fitzpatrick as well. And so just for the marine focused people, here's Jacques Cousteau, who is sort of the icon for the older marine generation. He's still, well known in the younger circles too. Now, he was not a scientist by training. He was, he was a naval officer, but he had an intense amount of curiosity, and he was very inventive. And so he, came up with a lot of inventions. The scuba system that we still have today, he was the co-inventor of, and a number of other technologies that he utilized. And plus, he was really good at using media. So he won 2 Academy Awards for Best Documentary for his work, early work on some of his films. And then, of course, he had The Undersea World of Jacques Cousteau, which was really what brought the undersea world to many, many people in this country and around the world. But there was a quote of his that I think is really pertinent. He said, "I'm not a scientist, I'm an impresario of scientists." So he was the one that brought the scientists together to do these expeditions and do the kinds of multidisciplinary expeditions. But anyway, he's a good example of someone who really had a scientific curiosity about the world, but he wasn't a formal scientist, but he made a large mark on the world just due to his sheer, sheer interest in the world and wanting to know, what's below the surface and how can we visit it and how can we be part of that world. What can we invent? What can we do to kind of open that up to humans? So why do we explore today? Again, we have this stereotypical image of the explorer going out to, going to foreign places and doing things that people haven't done before. But that was sort of what used to happen. It still happens to some degree now, especially in the deep ocean. But now I look at it as exploration is a way to prevent blanks from reappearing on the map. So we have a lot of problems and threats in the world, and we really need solutions to those. And so exploring what those possibilities are, and then trying to, I like to say, preventing, blanks from appearing. We don't want things to disappear, whether it's our coastlines or our animals or our habitats. We run the risk of wiping them off the face of the planet. So now it's more about let's keep the stuff here instead of, filling in the blanks on a map. So another thing that I think people think about with exploration, they sort of confuse it a little bit with adventure, and those two kind of things go together. But I like this idea that Bill Stone, who's a cave explorer, said that basically it's information. If you don't come home with data, you've done nothing. It's a stunt. You've accomplished nothing. So really, I stress with students, especially when we're doing field work, you really want to get information. And in a lot of cases, you might be going to places you may never go again. So you really have to be really mindful of what you're seeing and paying attention to that and figuring out how you're going to document that, how you're going to, capture that information that you can share with others, because you never know when that information could become useful. And I'll talk a little bit more about how that works in just a second. But anyway, that's a key thing. You want to get information. You're not just going out there to joyride or have a good time or whatever. Those are things that can happen, but you really want to get information and pay close attention to what you're doing. So this is just kind of a little map to show you some areas where there's still sort of, if you want to take the traditional explorer view, some areas that are still relatively undiscovered. There's areas in Central America, like the Darien Gap area in Panama, areas of the Amazon rainforest, Congo rainforest, Myanmar, Marianas Trench, obviously underwater, Great Barrier Reef also, parts of it are still fairly, not well understood. Borneo and the Kamchatka Peninsula. So there's still, and then Antarctica. So there's still places out there that you can go that we still don't know a lot about. But when I start talking about citizen science, you'll see that there's a lot of things in our back door that we still don't know about. So you don't have to go to Antarctica or the Congo to really make discoveries. But anyway, this is, a lot of people say, well, where would be some places that are still sort of unknown? And these are some examples of that. And this is Robin Hainberry Tennyson. He's a writer and expedition leader. He's conducted many explorations over his career. But basically, this was in the Explorers Club Journal a number of years ago. But he said, basically, exploration is now about understanding what we know about the planet we live on, but we need to put all that knowledge together to find solutions to our problems. So that gets back to that, what I said just a couple slides ago about wanting to, really exploring how to fix things or how to find solutions to things and having a mindset to be able to do that. So this is another person that I want to show. And I always, I don't know if Adam, I can't remember, Adam, were you my citizen science class too? I don't know if you were.
No.
So. Okay. So anyway, you might have seen this person before. I always ask people, if you can guess who this is, I'll buy you lunch or dinner or something. Most people don't know who this is, but I consider this guy a pioneering explorer. He has since passed away, but he's been a critical person, especially in this sort of new age that we're living in. And his name is Don Swanson. He was an information scientist at the University of Chicago. He's since passed away, but he kind of came up with this idea of, it's now called Swanson linking, and you can look that up and there's a definition for it and everything, but it's basically literature-based discovery. And he was coming to the realization that as more and more data is put online, we have just so much vast amounts of information that we're really missing important connections that we're just not seeing, because we just have so much information that is overloading us, and we're just barely able to get our heads around it with algorithms and big data management, but it's still overwhelming. And so what he basically did is he believed that excessive specialization could inhibit scientific creativity. And so, nowadays, a lot of people get very, very specialized. And with exploration science, it's really a broad multidisciplinary approach to things. And so he started to look at sort of wondering if there are ways to mine databases to make new discoveries. And so he basically was looking for this undiscovered public knowledge that exists in a lot of these open source databases now. And what he came up with, what he found, sort of his claim to fame, was basically he had some friends who were ill and they had Raynaud's disease and they had bad migraines. And he started looking at the Medline database, which is a database of scientific research papers. It's vast. And he was starting to look up these things, and he found these disparate connections that were mentioned in these different papers that all the research scientists had missed. And so he was the one that connected the use of magnesium to treat migraines, and that fish oil and Raynaud's disease, there's a connection there. So he did all that. He's not a doctor, and he's an information scientist, but he just said, I have access to this database. Maybe there's something the doctors are missing, because his friends weren't getting anywhere with their doctors with these problems. So anyway, that kind of launched a new type of exploration, which in this new digital world, or not so new, but it's rapidly evolving and growing, is the digital world and the databases that we have now at our fingertips, and what you can find exploring those. So I like this person, Mark Olson, talked about working with Don Olson, saying that basically he was doing science without dissecting a salamander. He was doing experiments with information. And that is, I kind of feel like that's sort of the 21st century area of exploration, where you're going to be looking at ways to get your head around big types of data to figure out like what are patterns in things, what are trends, what are there things that we're missing, what can we do with this to be productive and try to solve some of these problems that we have. So the other person I wanted to mention is David Cuomo, who you might know of. He's a journalist, again, not a formally trained scientist. He has a degree in English literature and an MFA from Oxford. But he wrote a book a few years ago called Spillover, which if you've not read it, I highly recommend you read it. It's a fantastic book. It totally predicted the coronavirus situation. It's all about zoonotic, viruses and how they jump from animals to humans and the potential for all that. So almost 10 years ago, he was writing about this. And basically, I mentioned him because how he got the idea for this was he was on an expedition with Mike Fay in the Congo rainforest. Mike Fay was traversing the equatorial rainforest in Africa, and David Cuomo joined him for a few weeks. This was a trip that took over a year for Mike Fay to do. And David Cuomo joined him at several points in the trip. And they came across one area where a whole group of gorillas had died, and they didn't know what killed them. And some of the indigenous peoples, there's the pygmy tribes that live there, were saying, "Oh, there was a disease that was here, that killed them." And they're like, "Well, what was that?" And they, ended up finding out it was Ebola. And so the book is really about how Ebola got to be came into the human population. But it's definitely laid all the groundwork for what's happened with the coronavirus and what we've been dealing with for the past year and a half. So the book really focuses on Ebola. There's the virus, but that kind of leads us into this era, the coronavirus era that we're in now. And so taking the elements of exploration science, where did this come from? And, to really rapidly get our heads around what happened with this virus. What do we know about it? How do we know what it's about? What is it? And how do we find out more? And we have to do this quickly because it's killing lots of people. So you really have to start to look across disciplines to figure out what was happening. You have to look at the biological factors, the ecology of how this thing lives in the wild, and then the anthropology. How do people handle something like this? And then, of course, goes without saying, the politics and the economics and all of it that kind of go along with it. But basically, you have to have this exploratory mindset to try to figure out how these pieces fit together and to come together to deal with a problem like this. So, so that leads me into sort of citizen science. So exploration science is this broad framework of multidisciplinary skills and a broad, open-minded approach to things. But citizen science is starting to leverage, people outside of formal scientific training to really help add information to fill in the gaps. And so citizen science is become a really a formally recognized discipline now that really enables inquiry. And that's really been made possible through technology, which I'll talk about in just a second, a little more detail. But basically, it's really expanded the reach of citizen science. Citizen science has been around for a long time, but it's only in the last decade or so that it's really gotten a lot of momentum. So just a little background in that, just to show you what the long history is of citizen science. I wouldn't consider this citizen science, but it does show you we were wondering about the world around us and documenting what we were seeing and experiencing. The Chauvet Caves. I'm not sure if I'm pronouncing that correctly. But basically, 30,000-year-old cave paintings, these elaborate paintings of the animals that were encountered in the southern France at that time. So we began documenting things that, there's earlier examples of that, but this is just some of the more dramatic examples of that kind of documentation. But people were documenting locust swarms, 3,500 years ago, 1,200 years ago. People in Japan were documenting the flower blossoms when those were happening. Wine growers in France 640 years ago were documenting when the grapes would be coming to season. And then in the mid-18th century, the Norwegian monks were really categorizing or collecting and documenting a lot of natural history that were happening around the monasteries where they were. So there's a long history of people like looking out at the world, wondering what's there, documenting it, seeing it, and then saying, yeah, what is this all about? What's going on? So, I say citizen science, and we put that in quotes just because, they've been the ones that have been collecting all this data over these years. They haven't been formally trained scientists. And like what I said earlier, our idea of a scientist, we kind of have this preconceived notion of it, but the professional scientist is really a fairly recent phenomenon in the world. Professional scientists have probably only existed really for maybe 150 years, maybe not even that long. And so all the time before that, our understanding of the world just came from curiosity. People kind of like, what is that? And why is that there? And, what's causing this to happen? That kind of thing. So, then you started to move into the realm of professional scientists. But even I mentioned these two folks, Ben Franklin and Charles Darwin. Franklin was a statesman, obviously, and he was not a formally trained scientist, but he was intensely curious and experimenting all the time with different things and coming up with his own sort of observations about the world. And then, of course, Charles Darwin, a lot of people, I think he was a formally trained scientist, and he was not. He was trained basically, he was trained in theology, and he basically went aboard the Beagle, just sort of as a kind of as a favor, really, like, here's an opportunity to go to sea and, kind of just be part of this expedition. But he was a really good observer, and he was really good at documenting what he was seeing, and really good at sort of taking all that in and sort of mulling it about for many years after he returned, before he finally published his groundbreaking publications. But he was not a formally trained scientist. He was just a very curious, intense person that noticed something that no one else had seen before. There's other examples, Alfred Russel Wallace, a contemporary of Darwin's, who didn't kind of hit on natural selection and evolution at the same time Darwin did. I mentioned Lewis and Clark because they were not scientists, they were military people, but they did a very good job of documenting what they were seeing as they moved out to the West Coast. These, of course, are, obviously white European explorers, if you will. But the big body of knowledge that largely gets ignored, and we're sort of rediscovering that, is the indigenous peoples. If we're still able to get access to their knowledge base, it is a tremendous amount of knowledge about the world that needs documenting and communicating more than ever. So anyway, there's some just little pieces of examples of really good people who've been really good at observing things, documenting things, that weren't formally trained scientists. They were citizen scientists, if you will, and they've made a big impact in the world. Now, I mentioned this guy, Daniel Smiley Jr. I don't know if any of you all are from up north, from the New York area, but there's a preserve up there called Mohonk, and it's up in the Catskill Mountains, kind of to the north west of New York City. And his family owned a big tract of land there, and there's now a preserve, and there's a resort on the other part of it. But Daniel Smiley spent his whole life at this piece of land, and he carried these little note cards. You see, he's got one in his hand there. Every day he would go out, and he would write down everything he saw. He would just everything, and he's like, you never know when stuff's going to be important. And he collected this huge database of these little index cards, but he was really meticulous about documenting the weather. And he was really the first person that almost single-handedly sounded the alarm on acid rain, because he noticed there's a couple lakes on their property, and he noticed that their lichens on the rocks started to disappear after rains, and he started to sort of test the acidity of the water and noticed, wow, this water is getting more and more acidic. And it was burning off the lichens when it rained, and the lichens that were at water's edge were disappearing. And, a lot of people don't pay attention to lichens, they're very subtle things on a rock. And anyway, he saw that, brought it to the attention of a chemist. He said, test this water. Why is this becoming this acidic? And they kind of figured out that, it's in the rain. It's, we're putting acid in the air, and it's coming down back onto the environment. So anyway, his collection of information now forms really the basis for the Mohonk Preserve database. And it is a very extensive database. And they have one of the most extensive weather databases for that part of the world. And you can go to their website and get all that data, all the weather data that he started, and all the other data that has collected meticulously on these cards, which they've now digitized. But anyway, he really truly was a citizen scientist. He was not a formally trained scientist. He was really reluctant to publish in journals because he didn't have a PhD. He didn't kind of like academia too much. He felt like it was a little bit too ivory tower for him. He liked to be out in the field collecting data and just observing things around him. But anyway, he's got a really interesting story. There's a great little book written about his life. Anyway, I just thought he's worth mentioning in the citizen science realm. So the role of citizen science, increasingly it's filling this gap of having we have fewer active professional naturalists out there and field researchers. That becomes more expensive and a rare commodity. And so citizen science can really fill a gap there. And so that's what's starting to happen. It's really leveraging people to be able to do that. So I'm going to can you all hear that? I don't know if let me just hang on a second. I think I forgot to turn on I forgot to turn on the audio. Sorry about that. This again. And where did it happen? There we go. Sorry. Okay. So let me just play this for you. This is about 5 minutes. This is a very good summary of the value of citizen science.
How are you ever, as a professional scientist, going to get hundreds or thousands of records of where a particular species is found if you don't crowdsource that data collection effort through citizen science? And that's what we're doing with iNaturalist. And again, we wouldn't be able to have those observations. We wouldn't even be able to answer these questions if we weren't using citizen science.
Oops, sorry.
I'm Greg Pauly, and I'm the curator of herpetology here at the Natural History Museum of Los Angeles County. And I'm also the co-director of our Urban Nature Research Center. The Urban Nature Research Center is a group of curators, scientists, and educators that all work together to promote some of our urban nature initiatives, many of which involve citizen science. And the basic goal is to get a better understanding of urban biodiversity and eventually to understand factors that structure urban biodiversity. Before we started using iNaturalist, we had a project here called Lost Lizards of Los Angeles. And the acronym for that was LOLA. And with LOLA, we received over a 4 or 5 year period, we received about 350 observations. And of course, now that I'm very active with iNaturalist, we might get 350 observations in an April weekend, for reptiles and amphibians in Southern California. But working on that LOLA project made me realize the incredible power of this approach, particularly in urban areas. And of those 300 and some odd observations, we had several new county records. All of introduced species. These were actually all introduced geckos that had never previously been documented in this region. And so I'd already recognized that using photo-based citizen science was going to be a really important tool. And then at the same time, I moved here to Los Angeles to take this position, and I was out on a jog, and I saw a Southern California legless lizard crossing the street in North Hollywood. So this is like absolute, stereotypical suburban neighborhood, just houses, north, south, east, west streets for as far as you could see. And here's a legless lizard crossing a completely urban street. But what I realized is, is this somebody's escaped pet, or are these actually managing to make it right here? Is the soil here sandy enough that this species is making it? How are we ever going to be able to answer that question unless we have people out doing lots of surveys? And even if you had professional biologists out doing surveys, what are you going to do? Walk sidewalks? How are you ever going to get the animals that are, in somebody's backyard, underneath a pot, in their mulch pile, et cetera? How are you ever going to document that? And so from those two experiences, from discovering these new species with our previous citizen science project and from my own observations, I knew, once I sort of figured out what iNaturalist was about, I knew that this was going to be a really powerful tool. Even then at the time, though, I would say that this is sort of one of the tools in our toolkit for studying urban biodiversity. And now I don't even sort of say that. Now I just say, this is the tool for doing urban biodiversity research, at least from my perspective of somebody who's studying things that people can easily photograph. This is the way we get our data. And I think in the best scenarios, in the best projects, it's generating data that allows us to answer questions that otherwise we wouldn't ever be able to answer. So alligator lizard mating behavior is a great example. So I started up the Rascals project, and in 2015, what I realized is that in sort of late March and early April, about a third of our observations of alligator lizards, southern alligator lizards, were species that were in mating holds. And that's where the male bites the female on the back of her head or sort of the upper part of her neck, and they may stay in this position for an extended period of time, in some cases over a day. And this is sort of their courtship, and eventually they may mate. And we were getting large numbers of these observations. And so what I realized is that when we think about sort of citizen science, amongst the many things that iNaturalist and these photo-based citizen science projects can do is not only document where things are found, across a spatial landscape, but they can also document interesting behaviors. And so I realized that we could sort of expand this and promote this and suddenly get a much better idea of when these species, when alligator lizards, for example, are breeding. But then you can ask questions like, okay, well, given things like urban heat island effects, do urban lizards breed earlier than rural lizards, right? If temperature is important in when they breed, that might be the case. Or, what's the latitudinal gradient in the timing of breeding? What's the year-to-year gradient? How much is weather determining when these guys breed? So you can actually learn, a whole lot about the biology of these animals as long as you can get enough observations. And the incredible thing is that in the entirety of the scientific record, there are 3 dates of when alligator lizards have been observed breeding. Just 3 dates in the peer-reviewed scientific literature. As of yesterday morning, we're at 144 observations accumulated over just a little over 2 years of promoting this via citizen science. So, the real story here isn't that we're studying alligator lizard mating behavior. We are doing that, but I think the really crucial part of the story is it demonstrates that citizen science is really this, revolutionary tool for studying animal behavior, because suddenly you can get huge numbers of observations of these incredibly rare events. It is still the case that I have never seen alligator lizards breeding, and yet I have the largest data set of alligator lizard breeding behavior. Still never seen it though myself.
Okay, so Dr. Pauly is talking about iNaturalist, which is a platform that a lot of people use to document biodiversity. I'll talk a little bit more about that. But what I'm going to be eventually getting at is making the leap from this to sort of sea level rise documentation in a citizen science context. But he really encapsulates, I think, very well, articulates, what the value of citizen science and how that can really be helpful in discovery and exploration and understanding, things that we just need a lot of observations in order to get our heads around. So basically in 2014, that's when citizen science as a term sort of entered the Oxford English Dictionary. And it's basically defined as scientific work undertaken by members of the general public, often in collaboration with or under the direction of professional scientists and scientific institutions. And it was first kind of used in that context, in MIT Technological Review in 1989 is when the term was really first used in the way we use it today. And in this country, you can go back probably the most significant citizen science project, if you will, has been the Audubon Christmas bird count, which started in 1900 on Christmas Day. It was started by Frank Chapman, who worked at the American Museum of Natural History, an ornithologist, and kind of a large figure in the bird conservation world when they started to really try to conserve birds. And the Christmas Day used to be a hunting session. People would go out and shoot as many birds as they could on Christmas Day. And he said, no, let's stop doing that. Let's start counting them. So that's been going on now for 121 years. And it's built up a huge database that's really enabled us to get a really good understanding of bird populations. And so birders are an interesting group. I don't know, some of you may be birders, but birders are usually very fanatic and they're very passionate about what they're doing. And they also are quite knowledgeable. So they really are citizen scientists. They really know a lot about the biology and the ecology of the birds. They know all the subtle differences, the bird calls, and it's just a huge group of people that are out there always looking around and essentially collecting data. So what a lot of these observations have done, and this was on the cover of Science in October 2019, is this unfortunate, problem of losing 2.9 billion birds since 1970. The Christmas bird count and the work of Audubon and citizen scientists has really been the ones that have helped document that decline and really given a lot of the evidence of it and given really all the data to support this. So these are two individuals who in the sort of the current era of citizen science are worth mentioning. Alan Irwin wrote a book called Citizen Science in 1995. He's really a social scientist. He really believed that citizen science is something that people in their communities should get their heads around, that you should be actively involved in the scientific process in your community, even if you're not a scientist by training. Rick Bonney works at Cornell. I think he might be just retired, but he worked at Cornell and he was really working to develop these contributory models where people would go out and collect data and contribute data on birds to Cornell's initiatives to kind of understand bird populations. So they've been kind of two big people in the last 25 or 30 years or so. So now citizen science is, now it's really formally coalesced into a discipline. There's a Citizen Science Association now, which has a very broad membership base. And then there's a journal. They have a journal now called Citizen Science Theory and Practice. It's an open source journal. Anyone can download it and look at it. And it really covers the whole gamut of citizen science. It's really a great publication. They also have a biannual conference. In fact, they just wrapped up this year's virtual conference. So it's really become a big group in a very formalized setting now. And then I should mention SciStarter.org. This was started by Darlene Cavalier's a master's project. SciStarter is really a website that's a big database to sort of collect all the citizen science projects that are being done out there and connecting people that might want to be able to contribute to those projects, kind of putting that all sort of under one umbrella. And I'll show you that website in just a little while. But basically, it's done a lot to help bring together all these disparate citizen science projects under sort of one umbrella so that people can find them and share them and contribute to them. Also, citizen science got a big shot in the arm with the Crowd in the Cloud documentary series, a 4-part series. And you can go to crowdinthecloud.org and watch all 4 documentaries aired on PBS. But it really talks about the coming of age of citizen science and what it means in this world that we're living in now. And the federal government has gotten on board. The Crowdsourcing of Citizen Science Act of 2015 was introduced. And now the federal government has a formal website for citizen science called citizenscience.gov, where there are tools available for federal projects to incorporate citizen science into their work, which has been nice. And then, so some of the appeal of all this, the reason citizen science, I think, has gotten a lot of traction is because of something like this, where the discoveries need not be monumental in order to reward curiosity enough to elicit more of it. So, people get really thrilled when they find something, and it may not be earth-shattering. It could just be some small thing, but it keeps them motivated and it makes them more curious. Well, why is that here? Why did I, just like the scientist was saying earlier, I saw the legless lizard crossing the street. Well, why is that there? It's it was a small observation, but it has big ramifications. Why is this thing here? What does that mean? So that's some of the appeal of citizen science for people. I think they can feel like they really can contribute to something and make a difference. The other big cornerstone of citizen science that couldn't be what it is today without technology. And of course, this is the first iPhone appearing in 2007 and ushering in the smartphone era that we're in the middle of now. And basically, these technologies that were introduced, which are sort of maturing daily, biometric sensors now on these devices. There are multiple cameras with 4K video and high-res still imaging, processors that the processors that rival desktop computers, solid state storage, and they have all these light sensors in them now. And then they have cellular, Bluetooth, Wi-Fi network radios, augmented reality, accelerometers, gyroscopes, GPS systems. All these things are built into this little device, which is only it's barely, between less than 5 ounces and, between 5 and 6 ounces, which is really incredible to think about. All that, we're carrying all that around in our hand. And it really has been the enabling device and group of technologies that have made citizen science explode. And so along with that has been, of course, the rise of the internet and the graphical user interface of the internet, which is the World Wide Web. And we have things like collective intelligence, where you have groups of people kind of working on problems. This has really happened in the mathematical world. A lot of theoretical mathematicians used to kind of work in isolation. And a number of years ago, one of the mathematicians put a problem he couldn't figure out on a blog. And within, I think it was within a month or so, they collectively, other people were able to help them solve that problem that these mathematicians have been working on for years in isolation. So collective intelligence can be quite important with these new technologies and ways of communicating. But serendipity, just like going back to Don Swanson, the serendipity, it plays a big role in all the things we look for on the internet now. We go down rabbit holes, but sometimes those rabbit holes can lead us to interesting places. Goes without saying, social media has played a huge part in all this. Crowdsourcing goes hand in hand with citizen science. It's pulling together all this information from a lot of people. And of course, cloud computing to process everything, and the open data now that we're having more and more of. so access to information. And now optical fiber networks, which are moving data faster and faster, and now wireless broadband networks in the 5G spectrum that are enabling even, faster and faster, sharing of information and access to information. So all of that's really helped build a sort of a tsunami of citizen science. And this is a guy, another person I sort of asked people if they ever heard of JSB. I don't know if any of you have heard of him or recognize his picture, but this is John Seeley Brown. He's sort of a key person in the technology revolution or evolution. He used to be the former director of Xerox PARC, which is the Palo Alto Research Center that Xerox used to have in Silicon Valley. And that is the famous research center that Steve Jobs visited in the 70s, where he saw them working on Ethernet, laser printing, the graphical user interface, which the Macintosh would adopt, and the mouse. We're all in the lab there that John Seeley Brown was overseeing. But basically, he calls these smartphones these curiosity amplifiers. So they've really become the megaphone for explorers and citizen scientists. We have the digital Swiss Army knife in our hands now that can amplify our curiosity and help us, ask questions, answer questions, solve problems, and communicate all in this device. So, this has resulted really in an explosion of citizen science projects across the board. We see grassroots citizen science projects. I'll talk about one in a minute. There's a lot of data and image analysis where people are, submitting lots and lots of images and data to be analyzed, and the collective problem solving, like I mentioned with the mathematics. Then the data collection, just the sheer amount of data collection that can be done through citizen science. And then citizen science can really become a valuable tool for establishing baselines. And that can be important when we start segueing into sort of sea level rise, where where are we with sea level rise, and what's changing about that, and how we're going to document that. So citizen science now is really there are models that have been developed on how to build projects, and there's really three main ones. One's a contributory model, a collaborative model, and a co-creative model. And the contributory model is really where you've got a scientist that says, hey, I just need to go out and collect data. And so using a platform like iNaturalist, like that other scientist was talking about, going out and just sort of making observations and collecting that information, you're just contributing to a database, basically. Whereas a collaborative citizen science project would be something that may be more of what Xavier and you all would be doing, where you've got a scientist and you've got maybe artists or other people that are working closely with the experts to maybe define a question or a problem that you need to collect data around, or try to get an answer to. And those are more collaborative projects. And then finally, there's co-creative projects where the community might have a lot of really specialized knowledge, but they don't have the scientific knowledge necessarily. So they find an expert to kind of co-create a project, around a question or a problem to collect data around. And so they really become the active creators of the project, as opposed to just a passive, data collector. And I should add that citizen science isn't perfect. There are times where the data that's collected isn't perfect. There's problems and errors with it, but there's also problems and errors with professional science data collection too. That happens also. But citizen science across the board, it's being shown that for the most part, it really can contribute really good data if it's used in the right way, in the right context. And so some of the common elements for that is basically, you want to work with an expert to help answer a question or tackle a problem, or whatever it is you're doing. You want to have the information that you're collecting should be open and accessible. If you've got the public collecting data for you, they want to have access to that data. And really leveraging the wisdom of the crowd and a crowdsourcing approach to things, that's a common element in these projects. And it's really important that you develop protocols that can be closely followed and well developed to collect the data. Because if you don't do that, the data can be very suspect. So, and then finally, you really want to assess your project. How well are we doing with this? Does it need to be tweaked? Are we reaching the audience we need to reach? How are we disseminating all the data and information that we're gathering through the project? So those are some common things. And then a lot of citizen science projects encompass a large geographic scope. A lot of them center on phenology and seasonal changes. That's a common thing to see. And then a lot of them focus on very large data sets that need analysis. So it's just too cost prohibitive to have one or two professional scientists do analysis when you can sort of leverage artificial intelligence, machine learning, machine vision, things like that to kind of analyze things to help you out from data sets that are collected by the public. And then a really key thing with citizen science is really developing protocols that enable the participants to collect the data themselves. And I really highlight in that red because, you see a lot of instances where scientists take people into the field to collect data and they sort of handhold them and like, well, this is what we do. And we collect this data and you come with us and do this. But then you go home and you're like, well, okay, in order for me to continue to do that, I got to go find the scientist and go out and do it again. But the idea with citizen science is that you've got a protocol that's been thought out well enough that a person can go out on their own and collect the data. And that's what you want. You want to leverage this group of people who are really motivated, who are very smart, who are very curious, and they want to participate. And they can collect good data if you just show them what you need, and they're going to let them sort of turn them loose. So anyway, those are some things that are sort of foundational things with citizen science. But it isn't all about collecting data. This is a link to an article in Slate about how non-scientists really should take part in research priorities and even more, more about the scientific process and getting involved with that. So it's definitely reaching kind of a tipping point where we're seeing kind of some of this stuff happen now. So let me go back to this. And so, oops, sorry. Some time for questions here at the end. I'm getting close to the end, so bear with me. So this is, I don't know if you know who this person is. This is where things get a little bit serious with citizen science. This is, if you don't know who this is Aaron Schwartz. I would have to say, unfortunately, the late Aaron Schwartz. I'm going to play this trailer for a documentary about him, but he clearly played a pivotal role in the open data movement that we kind of have now. And so I just want to play this trailer of his documentary because he really is a profound figure in this whole movement of open data.
It's easy sometimes to feel like you're powerless, like when you come out in the streets and you march and you yell and nobody hears you. But I'm here to tell you today, you are powerful. You can stop this bill.
A co-founder of the social news and entertainment website Reddit has been found dead.
Aaron learned how to learn at a very young age.
Bob introduced him to computers, and he just took off.
He certainly was a prodigy, although he never kind of thought of himself like that.
He really had different aspirations for the purposes of political goals.
He was sort of learning to hack politics.
Stop SOPA!
This bill poses a serious threat for all who use the internet.
The freedoms our country had been built on would be suddenly deleted. I couldn't let that happen.
Aaron was trying to make the world work. He was trying to fix it.
Bringing public access to the public domain.
He doesn't hack JSTOR in the traditional sense of hacking.
He wasn't stealing, he was making a point.
They arrested him, strip searched him, and left him in solitary confinement.
He said, they want to make an example out of me.
On the internet, everybody has a license to speak. It's a question of who gets heard.
Aaron Schwartz was not a criminal.
You can say, oh, this is another instance of cyber war. The cyber criminals are attacking us again. They use those as excuses to push through more and more dangerous laws.
This is a poor use of prosecutorial discretion.
Should have never gotten the attention of the criminal system.
We need to galvanize opposition today because today is when it matters.
I'm still angry. This is what we as a people think is okay.
Aaron was willing to put himself at risk for the causes that he believed in.
He was the internet's own boy, and the old world killed him.
So, whoops, hang on a second. It's my keyboard died on me. So yeah, Aaron Schwartz, it's sort of a tragic story. He committed suicide. He was about to be prosecuted by the federal government. Basically what he did is he took journal articles from JSTOR, basically research that had been funded by taxpayer dollars, and he wanted to put that out there for people to access. And like they said in the trailer, they wanted to make an example of him. And so they really went after him. And he was really a figurehead in the Creative Commons movement, if you're not familiar with that. That was Lawrence Lessig that you saw in there. He was a lawyer at Harvard who pushed that through with Aaron Schwartz. And then in addition, Tim Berners-Lee, who created the World Wide Web, also saw him in that trailer. So Aaron Schwartz really kind of paved the way for the open data and open information that we're starting to see more and more of. So he's a key figure to kind of recognize. Also sort of, culminating in all this, we've got basic data collection that you can do in citizen science, but then you can really see how it can actually change things in a big way. And the big poster child for this was the Flint, Michigan water quality crisis and of 2014. I'm going to play this. This is a few minutes long. I think it's worth looking at. I know we're running short on time, but let me just play this. It's a very interesting story of how this happened, and then we'll talk a little bit about the sea level rise initiatives around this. So
we wanted to follow up on what Councilman Mays was saying about the lead test, so we went to speak with Kurt Guyette of the ACLU. He's actually an investigative reporter who's just won Michigan Journalist of the Year. We asked him about the work he did with Professor Mark Edwards, a nationally recognized lead contamination expert at Virginia Tech.
Sitting around one night thinking, how can we get to the truth? How can we get this beyond what was at point he said, she said kind of thing? And I thought, oh, well, geez, maybe we could do our own test, because I had some money in my grant to pay for experts to do research for us. And so I called up Mark and said, how much does it cost for each test? He said, no, $70. How much does it cost, or how many do you need, how many homes do you need to sample to get a scientifically valid sample? He said, oh, 50 at minimum, 100 would be better. So we started talking with the citizens, seeing if they thought we could pull it off. They were very confident that we could pull it off. Mark was confident that they could do it on their end. And so there was like this unique collaboration, really, between the scientists at Virginia Tech, me as a journalist becoming involved in it, and then the citizens themselves, who are really, again, in the forefront of, getting all these test kits distributed throughout the city. We ended up collecting 4 times as many as the city and state had collected in the previous 6 months in like a 3-week period.
And then there was Dr. Mona.
Yes.
Explain what she did over at Hurley Medical Center, the pediatrician.
So in August of 2015, the citizens working with Mark Edwards and this whole team of Virginia Tech, who were working around the clock. On this side, we're working like crazy to get the kits distributed and collected and making sure we're keeping track of everything, which was complicated. But, they were doing it with the index cards and everything. And then as soon as the sample kits started being returned, 12 at a time, we'd box them up and send them back to Virginia Tech. And they're working around the clock to get them analyzed, because as soon as they start seeing the results, they're going, oh no, this is bad. This is bad. By the time they got the first 24 bottles, they knew. There were so many with elevated levels that they knew that this was a crisis.
Okay, so I'm I'll just stop at that there. But basically, the Flint, Michigan water crisis was really a grassroots citizen science-based project and an emergency project, and it really brought to light the problems, the lead in the water, and really brought that to the national spotlight and forced government to change and try to clean it up. So this is a really good example of citizen science in action for really people taking initiative and saying, look, I've noticed something. There was actually a mother who noticed something was wrong with her children and started looking at is there something wrong with the water? And she's the one that kind of got things going to kind of look at this problem and bring it to light. But it couldn't have happened without citizen science. So anyway, so that brings me to sea level rise. I know we're running out of time here, but basically what I wanted to just show you was, obviously everyone's seen these scary, maps of sea level rise in, 80 years from now. But basically here in Miami, there's a number of projects kind of tied to this that use citizen science and sort of an exploratory mindset. I See Change, which some of you might have heard of or even participated in, is one of the sites. This is I See Change is on the ground in a number of places, but it's gotten some traction here in Miami. And if I go to the website here, we can basically look at sightings, and you can basically, I use the current location here, and you'll see, people starting to see, May 27th, there was a water leak in front of the Miami-Dade College parking lot. Excuse me, there's all kinds of things people are starting to report here in Miami using the app and kind of getting on board with this data collection process. So, we're starting to see this kind of thing happen now. And I See Change it just started in Miami not that long ago. And then on SciStarter, if you go back to that platform I mentioned before, and do a search for Miami and sea level rise, basically you're going to find there's 4 or 5 projects in here. There's I See Change. There's a few others that are collecting data that you can sign up for and start contributing data to. These are contributory projects, but they can just shows you some examples there of what's possible. So, and then basically just sort of related to this are some other projects. These are not sea level rise connected, but they are connected somewhat to climate change. There's a City Nature Challenge, which Miami's been very active in the last several years. My wife's been very active in this, using the iNaturalist platform to document biodiversity in the Miami and South Florida areas. And then, so using iNaturalist, which has a very big database now of biological diversity around the world. And then finally, here in Miami too, there's Miami's working to improve this circular economy. They've got a project that's been going on that's started by a woman named Jenna Jambeck. And basically, again, this might be something you've heard about, but basically she has this Center for Circular Materials Management in the New Materials Institute. And she's started working around the Miami River area with the Ocean Conservancy in the city of Miami to kind of document where exactly is the plastic coming from and what, how's it getting into the water, looking at kind of the full cycle of that problem. So, so that's another example here on the ground where the citizen science is starting to take root. Miami Waterkeeper, which you guys are probably all very familiar with, has a number of programs. One of them in particular, this 1,000 Eyes on the Water, which is has its roots in citizen science. And then the Blue Scholars Initiative. If you've not heard of Blue Scholars, they're a fairly new nonprofit here trying to educate children, especially children from disadvantaged backgrounds, to kind of appreciate and learn more about Biscayne Bay. They're starting to kind of look at citizen science as well. And then Debris Tracker, Marine Debris Tracker, is also a big platform for collecting contributory data to kind of understand the trash problems better. And so really combining this philosophy and approach of exploration science with the tools and methodology of citizen science and putting it all to a problem like sea level rise, you can try to come up with solutions, or at least starting to collect the data to try to put together enough information to come up with solutions to this problem. So I know I kind of just whirlwind blew through all that, but anyway, that's the overview, and I'm happy to take any questions. I know we're about out of time, but anyway, happy to answer any questions.
Well, thanks. That was extremely helpful in many ways without really understanding it. We're all citizen scientists who were mapping our topography, right? Not just citizen artists, but citizen scientists, and sharing that data. And like the Flint folks, really being activists about it, raising a lot of attention as to the impact of rising seas in Miami. Another project I did, the longitudinal installation, asks you to contribute your 25th quote. That's more qualitative data, but nonetheless it is data where you talk about how you've seen Miami change through time. So these are all examples of work that should inspire us as a group beyond the initial planting of the marker. Again, there's visualizations that we want to create, but this might be a wonderful direction for our group to look at ourselves, not just as advocates, which I think is how we mostly see ourselves, but to see ourselves also as citizen scientists. And And it's, to me, the passion isn't just about specifically the data, but it's about how that data gets shared. Anyone can figure out what their elevation is, but to add a qualitative component to that, where people then explain whether that provokes anxiety or action, would be important. So I thank you for that. I know our chair was just here, he'll be right back, but are there any questions in the meantime? You can put them on the chat or you can ask. Well, I wanna, here we go. Here's a question from Stephanie. Can you read it yourself there? I mean,
I'll read it out. It just says, that was an amazing presentation, Keene. I have one question. Do you think social media can be used as a form of citizen science, participatory way to engage people into the conversations of climate change? If so, what advice do you have?
Yeah, I think it can. I think it, you know, yeah, I think it can be. You just have to, I think a lot of people might, I think when you're going to use social media, you gotta really think it through how you're going to use it and leverage it. You know, it's sort of a Pandora's box. At least my personal feeling of it is it's sort of a double-edged sword. I could talk a lot about what I see some of the problems with social media, but yeah, I think it definitely, you know, in a lot of ways, these sort of contributory projects are kind of sort of a social media ask about them, because you're collecting data that's open and accessible and people are sharing it. Just like you saw that feed from the IC change, you know, people are putting out their observations and that sort of thing. So, you know, people can mine that data to perhaps look at people's perceptions or find observations that people might be making sort of informally in social media. I think social media for citizen science has largely been used sort of to let people know about projects and connecting them to people that are doing the citizen science projects. And then once that happens, then the people can, you know, start to contribute the information and get involved. So I think that's mostly how it's, you know, been used that I've seen. So. Yeah.
I had a question. If you could, all the links and the platforms that you brought up at the end, I had never seen any of them. So if somehow to share that, I don't know if I'm on the email list. So maybe through Adam.
So this video will be posted anyway, so you can see the entire lecture again. But yes, if there's a way of emailing something, that would be really nice.
Yeah, I can, Jamal and Adam, I can email you the links to these things. Sure. Yeah. The IC change one is that one's a good project. It's pretty new in it's probably like a year old here in Miami, maybe not even a year old, and it's a good one. So hopefully that you know can start to collect a lot of data about, again, it's sort of this baseline, you know, the idea of these baselines is like, okay, where are we seeing things happen, and sort of like seeing the legless lizard crossing the road. It's like, hey, I go down the street every day and all of a sudden I'm seeing water bubbling up through the grate over here. Like, I've never seen that before. Why is that happening? You know, or it's a sunny day, but I'm seeing flooding in the street. I've never seen that before. So things like that can be, you know, just a good examples of sort of observing, you know, paying attention to the world around you, observing it and trying to figure out, hey, this is different. This has changed. What's, you know, what is that? What's that all about? So, yeah.
Yeah, the fish kills in Miami had a really coalescing effect, and water clearly able to bring people in. Hey, Brian, I just want to bring you in. Welcome. I don't know if you wanted to say anything or say hello or something.
No, I appreciated the talk. Keene, it was very interesting, and I think it's something that, you know, more traditionally trained scientists like myself are grappling with, how to you know, bring this into our science in a better way, and I think it was very informative. I think one of the things, the clip you made from that individual that was worried about open access, that's something that's a big issue, and we're also struggling with that because of you know, it is expensive to get subscriptions to these things if you're not affiliated with the university, and that limits the availability of this original published work that could get out into the community. And the flip side is this, you know, I get every day some solicitation from some journal that may be open access, but they have hidden fees in there too. So it's just kind of a wild west in that world, and it just kind of has caused me to retreat a little bit into what I know, and so but hopefully we can get beyond that and have a lot more of our work available as open access.
Yeah, no, that is true. Yeah, a lot of the open access journals, you have to pay a fee to make them open access essentially, and it's still not perfect, and it's but yeah, it's evolving. So hopefully, it's going to move in that direction, better. But yeah, that's definitely true. So, and again, citizen science, it's not perfect. I mean, there's definitely flaws with it. There's been problems with data collected and that sort of thing. So it's not always perfect, but as it becomes more and more accepted and evolves more, I think the project designs are getting better and better, where they're having checks in place to check the data. Is this, is this really good or not? And before they say, hey, can be released. Like iNaturalist observations have to be made, at least 2 have to be made by known professionals before it reaches a research grade. And then once it reaches research grade, it's released into the larger biodiversity databases that researchers use around the world. So it does have some vetting. They're building more and more of this vetting into these projects, so that it's not just you're like, well, can we really use that data? Are we sure about that? And that really has a lot of implications legally and in policy, because if you start introducing that kind of data and you use it in a policy forum, you could say, well, is that really accurate data? Is that true? And if you can't prove it, comprehensively, then it's like, okay, well, we're throwing that out, and then you lose the power to make policy changes and things like that. So it's still early days, and it's not perfect, but it's being clear that it has a lot of value, and I think more and more people are trying to get their head around how to use it.
Thanks.
Well, I know it's getting a little bit late for us, but and I don't think there's any other questions. Is there anything either Brian or Adam or Jamal want to close with before thanking Keene for being here?
No, I don't have anything.
I'll just go ahead and say that we're going to be having our next meeting on July 7th. That's the first Wednesday of next month. So mark that down in your calendars, and we'll be sending in an email reminder about that. Otherwise, Jamal, is there anything you want to say?
Just thank you. It was a great presentation. I learned a lot.
Thank you.
And I definitely see potential for, especially when the impacts start getting more and more pronounced. I think you'll see a huge kind of surge of citizen science, possibly unintended, from people just taking pictures and hashtagging. But yeah, I definitely see the future.
Yeah, and one thing that's really interesting development is really the machine learning that's going on with the data analysis stuff. iNaturalist has uploaded large libraries of images that the computer algorithms are learning, like what are all these things, and the identifications get faster and faster and more accurate. Of course, when rare things are uploaded, they don't have images of those things, so they're like, well, those take a little more closer analysis, but they're building that kind of thing into more and more. There's a platform called Zooniverse that has a lot of data analysis projects in it, and they're using a lot of machine learning algorithms to really filter through millions and millions of images to look for data and patterns and things like that.
Well, thank you so much, Keene, for spending time with us and sharing all your knowledge. And Judy, we will get that email to you with those links.
Yeah, I'll get those to you. Yeah.
All right.
All right. Thanks,
Good night, everyone.
Xavier. Thanks, Adam, Jamal. Thank you all. Nice to see everybody. Thanks, Brian.
Good night.
Okay, good
Thank
night.
you.
Take care.